So today we are going to solve one more problem from optics. That question number is 27. The interference question. In the question is given, you have a oil, thin film oil having thickness 255 nanometer, and its refractive index is given 1.47. As a normal incidence of white light. As the question is, as a result of interference, which color will be dominated? So there will be interference due to reflection from this interface and this interface. So after interference, as a result of interference, which color will be dominated? That we have to check. Okay. As you know, for constructive interference, so the color will be dominated, for which will get constructive interference. So for constructive interference in thin film, the condition is like that: 2 mu t cosine r, that should be equals to cosine I or r, that should be equals to n plus half lambda, and that n can take values 0, on, 2, and so on. And for normal incidence I and r, that angle will be 0. So obviously cosine I or r, that will be on. So we'll basically get twice mu t, and that will be n plus half lambda. So that allowed values of 0, on, to n, the allowed values of n is 0, on, to 3, and so on. If I take n equals to 1 here, if I take n equals to 1, so this will be 3/2 lambda, right? It means I'll get lambda. If I take here n equals to 1, I'll get this factor, that will be 3/2 lambda. It means the lambda will be basically, or basically, yes, the lambda will be here 4 mu t divided by 3. 4 mu t divided by 3. So if I substitute this value, we'll have 4 by 3, mu is 1.47, and t is 255 nanometers, so it will be -9 meter. Okay. It means to calculate this value, lambda will basically come around 500 nanometer, and that is basically green. Thank you. So this will be the option, that wavelength of interfered light that will be dominated, that will be green, having wavelength 500 nanometer.